Okay, so we're dealing with another type of inequality here. This one right here is a quadratic inequality. Now, just a tip on quadratic inequalities. We want to be sure that on one side of the inequality sign we do have a 0. So in this case, we do have 0, and we're going to start off by factoring this right here. So we've got x squared minus 6x plus 8. So let's go ahead and factor that right quickly. So we want the factors of 8 that add to give us negative 6. And that happens to be 2 and 4. And in this case, it's x minus 2 and x minus 4. So we're going to make that greater than 0. So this is an equivalent statement to this. All right, these two things are the same thing. This is just in its factored form. Now what you're going to do is you're going to do a very loose application of the zero factor property. So we're going to state what x equals there and what x equals there. In this case, x equals 2, and in this case, x equals 4. So here, x equals 2 and x equals 4, and we're going to use that. We're not done yet. What we're going to do is we're going to figure out, well, where we would have an area of truth, okay? And wherever we have, an area of truth per se, well, that would be part of our solution. So let's go ahead and draw a line, all right? And it's, just think of it, it's a number line. And I'm going to put on this line, I'm going to put right here the number 2, and right here I'm going to put the number 4. Okay, so I'm also going to draw kind of these barriers underneath it. All right, and what I'm going to do next is I'm going to pick what I call test points. So let's just pick a test point. Now something before 2, a good number is 0. Something in between 2 and 4, oh, let's say 3. And something after 4, let's call this one 5. And I put TP, not toilet paper, but test point. All right, TP for test point. All right, so we pick these 3 test points. And what we're going to do here is we're going to plug these 3 test points into either one of these inequalities. So we're going to figure out, well, what do we get when we work this out? Now this is probably the easier one to work with. Remember I said they're equivalent statements. So this one is probably a little bit easier to work with. So what we're going to do is we're going to plug in 0 minus 2 times 0 minus 4. And we're checking to see if this is greater than 0. So let's check. So this gives me here negative 2. And this here gives me negative 4. And we're again checking, is it greater than 0? Well, negative 2 times negative 4 is positive 8. And positive 8 is greater than 0. Therefore, this right here is a true statement. 8 is, of course, greater than 0. Okay, now let's check the middle area. So here we have 3 minus 2 times 3 minus 4, and we are checking if this is greater than 0. Okay, so let's see. 3 minus 2 is negative 1. 3 minus 4, I'm sorry, 3 minus 2 is not negative 1. It's positive 1. What was I thinking? Okay, so here it is. It's 1. And 3 minus 4 is negative 1. I was jumping the gun there. All right, and we're checking if it's greater than 0. Well, this right here, the product is negative 1. And we're going to ask ourselves, is negative 1 greater than 0? Is it bigger than 0? And the answer is no. So this is an wrong. All right, not to be confused with the variable x over here. All right. So this is false. This is a false statement, so this is not part of our solution. Now we just need to look at this last region right here. All right, let's see here. So in here we're going to plug in 5 minus 2 and 5 minus 4, and we're checking if it's greater than 0. Remember, we're plugging it in this region right here. All right, so what's 5 minus 2? 5 minus 2 is 3, and 5 minus 4 is 1. All right, and 3 times 1 is 3. And so, of course, 3 is greater than 0. So 3 is greater than 0. So this area right here, this statement is true. So let's think about this for a second. Here we've got on our number line, I forgot to write it in, but there it is, negative infinity to infinity. We know that this is not part of our solution set, but this part is, and this part is. So we're going to include here a set of parentheses. So let's draw in a set of parentheses like this, and we know that we're going to shade everything to the left of 2, and we're going to shade everything to the right of 4. So that's going to help us right now with our interval notation. So we're going to go from negative infinity to 2 with a parentheses, and then we're going to use set notation, which says union. This means this area or this area. So this is the or operator. And so the last part is that the solution is in this area or it's in this area from 4 to infinity. So this right here is the solution set, all right? In set notation, we've got the union there. These are the two areas of where this inequality here holds true.